Hi, I'm Hafsa Osman from Team Hades, and our project statement is to build a mobile robotic arm that can be controlled using hand gestures. So we started off our project by assembling a 6-wheel rover that would help make our robotic arm be mobile. So we made use of a big sock and a motor controller initially. Big Sock is a popular open source autopilot system that's used in unmanned aerial vehicles. It is used to enable our rover to move autonomously. It's a platform that helps the UAVs to communicate with the ground control system. So we set up the RD rover firmware onto a Pixhawk, and then we calibrated the Pixhawk sensors and then verified the configuration by performing a parameter checklist. Sabertooth is a motor controller that can control the speed and direction of the DC motors. It can be used to control the throttle and steering of a robot. Throttle controls the speed of the vehicle, while steering controls the direction of the vehicle, that is whether it has to move left or right. And we programmed our rover to move. So rover programming refers to the process of creating a program that controls rovers that are vehicles that can be used for exploration or research in remote or hazardous environments. The programming that's involved in rover programming typically involves developing software that can control the rover's movements, such as its speed, direction, and orientation. So we made use of the DroneKit library while programming the rover. The DroneKit library provides a way to communicate with the autonomous vehicle platforms. So we programmed our rover to move in a non-GPS and GPS environment. In non-GPS environment, we make use of the vehicle channel overrides attribute, where channel 1 and channel 3 are the throttle and steering channels respectively. And in the GPS environment, we set waypoints so that our rover can move. So we make use of location global relative, which is a class in the DroneKit Python library. And it's used to define a GPS location in terms of its latitude, longitudes, and altitude. And along the way, we get started with Jetson Nano. Jetson Nano is a small but powerful computer designed for AI and machine learning. It is equipped with a GPU so that it can run neural networks parallelly. So we then installed ROS and NavROS on, and ROS is a robot operating system, and it's an open source framework that provides a collection of libraries and tools so that it simplifies the task of creating complex and robust robot software. NavROS is a middleware that's used to communicate with rovers or other unmanned vehicles using the NavLink protocol. So basically, NavROS is a ROS package that provides communication between ROS and a NavLink-based rover. So we then proceeded on to working with the robotic arm. We use ROS Gazebo for the robotic arm simulation. We are working with a 6 degrees of freedom robotic arm. A 6 degree of freedom robotic arm has 6 joints, each of which can be independently controlled to allow the arm to move in any direction and orientation within its workspace. So this makes it highly versatile so that it can mimic a human arm as much as possible. So this is what our project entails. Thank you.